So, good morning, everyone. So, first, I would like to thank the organizer. Uh, Special thanks goes to Dr. Velluri. Uh, and fourth, by 2030, India will reduce the carbon intensity of its economy by more than in the thematic area of carbon capture and utilization storage, climate change, clean or alternative fuels, clean coal, smart grid, building energy efficiency, and solar energy system. The program which I am handling at Department of Science and Technology is Hydrogen and Fuel Cell and Material for Energy Storage Program. And these two programs are coming under Mission Innovation. So before starting into the Hydrogen and Fuel Cell Program, I would talk something about Mission Innovation. So what is Mission Innovation? So the whole concept of Mission Innovation started in November 2015 when the heads of various different governments, including India, presented by our Prime Minister. So Mission Innovation Platform is one of the most powerful and enabling platform which brings a lot of countries and a lot of technologies on board and enable collaborations and collaborative effort to take on challenges that are global importance. And it is in that context, Mission Innovation 2 was launched to accelerate technology, particularly with emphasis on Paris Accord, which India is a part to. And that is the main idea, is to reduce the global warming and where energy becomes a very important part of the entire cycle. Mission Innovation was announced material for energy focused on identifying opportunities to support these four missions and one of the innovation community and their unique material needs. So some of those ideas are reflected in this slide. So we appreciate that Mission Innovation Initiative is at a slightly different stage of development. So Material for Energy would like to participate in your individual roadmap preparation in order to assess whether material acceleration platform could develop to apply to solve material problems that would advance towards your goal. So in some cases, we are already developing this self-driving lab to address missions need, especially the hydrogen and carbon dioxide reduction. So there is a major program called a battery storage under Horizon 2020 known as Big Map. So that works within the Material for Energy broader ecosystem. So one of our earliest intervention was on thermal energy storage material and would certainly be interested in developing the workflow developed with the affordable heating and cooling of building innovation community in this phase of mission innovation. So in order to get an idea how material acceleration platform could work for developing an electrocatalyst for the clean hydrogen mission, let us consider the electrocatalyst system under development by the National Research Council of Canada. Here, the schematic shows the closed-loop catalyst synthesis and characterization to achieve oxygen reduction using a low-cost metal oxide material. Artificial intelligence will be used to accelerate the electrochemical characterization, but also plan the next experiment from the available elements or candidate material space. So this system can directly apply to hydrogen production, and there are plans to integrate this in the future. So hopefully it will support work under the clean hydrogen mission. So the oncoming program that DST have stepped into now is focusing more and more faster innovation to bring the translational project into reality and at the same time do it in a cost-effective manner. So that was the challenge that the DST started out when it decided to take on integrated clean energy material acceleration platform. Here, IC map is divided into three verticals. We can see that bioenergy and hydrogen map, then we have material map, and finally the storage map. And if you see, each map has a number of PIs on board. So 10 PIs comprising bioenergy and hydrogen map. So each of these has a very discrete and concrete connection to our commitment to Paris Accord. So I should also mention that as far as the Indian contest, this has been a program, right from the start, it has taken up top-down approach. So it's a goal-oriented vision mode program, which we are trying to achieve through this. And what is common between all the three verticals is that every single vertical has a very strong role of artificial intelligence, machine learning, and data analytics. So that is inbuilt in each of these verticals. So that actually enable in silico processing, not only the data mining, through IC map that we have access to a large database, and through that, most of it done in a predictive manner rather than trying to do an experiment and to understand the results. So it has now become an inverted where the machine learning and data analytics combined with artificial intelligence is now trying to guide this entire program and enable material discovery at a faster pace and do it in a more cost-effective manner. So DST also supported two energy storage platforms. One is at IIT Mumbai, energy storage platform on hydrogen. So the lead PI is Professor Pratibha Sharma, who is sitting in this audience. So it has been established to carry out material and system research and prototype demonstration, ideas and industrial interactions, collaborations, then manpower development and information dissemination in the field of hydrogen. So information as well as the nodal point where the people in the country working in the area of hydrogen could be provided with mentorship or material or required help and support. So DST has supported this center with the total cost of almost 10 crore for 5 years. And the technology, metal hydride-based hydrogen purification system developed under this center has been transferred to NTPC. So another center also we have supported to NFTDC, and this center will be established in the Non-Ferrous Material Technology Development Center at Hyderabad with a core theme of hydrogen-based material to energy devices. So the focus of this center will specific to hydrogen-related system. Here you can see that the partnering institution, IIC Bangalore, IIT Madras, IIT Bhubaneswar, and Sri Chitra Thirunar College of Engineering, Trivandrum. Here, a total cost of almost 9 crore has been sanctioned by DST to support this center. Here are some of the key outcomes. Banaras Hindu University has developed a technology called cutting-edge quantum technology-based green hydrogen production. And this technology has also been transferred to Apparat Engineers Private Limited. And this technology was approved for implementation by the Indian Navy headquarters, joining hand with the Quasar Investment Company, UAE. So this is again, this is from the storage center. IIT Mumbai has developed a metal hydride-based multi-storage purification system, capacity of 6,000 to 10,000 liter per batch, delivering a 99.99 purity using a low-grade thermal input in the range of 30 to 50 degrees Celsius. So this technology has been transferred to NTPC. Then another outcome is from IIT Mumbai again, metal-based hydride, metal-based hydrogen storage system for two-wheelers, integrated with a PEM fuel cell, retrofitted on a two-wheeler for a 60-kilometer test drive. So this technology also be transferred to Center for High Technology, a technology cell of Ministry of Petroleum and Natural Gas. Now the main topic of today's talk, Hydrogen Valley. So what is Hydrogen Valley? The Hydrogen Valley is a mini hydrogen economy that integrates several steps of value chain and various end users in a regionally defined scope. So in the past, we have seen demonstration project mostly focusing on a single applications. So what is Hydrogen Valley? So Hydrogen Valley is the next development step It showcases the full potential of hydrogen as an energy vector. So the objective of Hydrogen Valley is to demonstrate how the technology development in the entire value chain of hydrogen, for example, production, storage, and transportation as an energy vector, fit together in an integrated system approach. So this concept as a national initiative to foster green hydrogen transition has taken up by the Department of Science and Technology for showcasing and deploying technology advancement at the industrial level across the green hydrogen value chain and creating an interconnected hydrogen ecosystem across the selected region of India. So I will be talking about what are the regions which we have selected. So as a clear sign of growing and maturing hydrogen market, Hydrogen Valley have started to emerge all around the world. So this slide shows the global Hydrogen Valley activities and examples project from the Mission Innovation Hydrogen Valley platform. Here we could see that a total 98 Hydrogen Valley in 36 countries with a total investment of 1,73,429 million euro. So Mission Innovation member together commit to deliver at least 100 large-scale integrated green hydrogen valley worldwide by 2030. By 2025, we have already 98. Now, India is also coming up with the 4 hydrogen valley. So this will generate economy of scale and pushing down clean hydrogen costs to catalyze the development of a global clean hydrogen economy. So what makes Hydrogen Valley? So in all the Hydrogen Valley, the concepts are unique and depends on the specific objective and the regional circumstances. So there are common characteristics of what constitute a Hydrogen Valley. Let us look into the first large in scale. All Hydrogen Valley go beyond R&D and demonstration. They are large in scale and have at least a double-digit million euro investment in size. So it typically also includes several sub-projects that make up the larger valley portfolio. And secondly, they have a clearly defined geographic scope. So Hydrogen Valley are hydrogen ecosystem that covers a specific geography. Their footprint can range from a local or regional focuses, for example, a major port or its hinterland, to a specific national or international region, for example, a transport corridor along a major waterway. Then third, a broad value chain coverage. It is very important. Along their geographic scope, Hydrogen Valley covers a multiple step in the hydrogen value chain, ranging from hydrogen production to the subsequent storage of hydrogen and distribution to off-takers via various methods of transport. Then fourth is supply to various end sectors. So Hydrogen Valley usually showcases the versatility of hydrogen by supplying ideally several sectors in their geography such as mobility, industry and energy end users. So thus, Hydrogen Valley are ecosystem or a cluster where various final applications share a common hydrogen supply infrastructure. So therefore, creating a synergy and more economic step for the participants. And finally, project feasibility. So project have to be under real development and at least working on feasibility study. So Hydrogen Valley focuses on green hydrogen for various end users in mobility, industry and energy sector. Upstreams refers to annual green hydrogen production of 8.5 million metric ton. So this is the global hydrogen I'm talking about. And the main type of water electrolysis technology used is PEM and alkaline. So midstream is the transportation and storage of hydrogen. And storage method mainly compressed gas hydrogen, cylinders, caverns and others. And transportation via pipeline, truck and ship. Then downstream pay attention to industrial off-takers, mobility end users and energy end users. So here is the schematic of HVAC. So the main scientific priorities and challenges for different pillars and activities are listed here. I'm not going to read out this. So somebody interested, you can take a photograph. So however, across different nations around the globe and the evolving hydrogen economy in them, so different terms and definitions has developed. So these include primarily hydrogen hubs that we can see in United States of America, in Australia, then hydrogen clusters. So that also we can see in China, Australia, and some part of the Europe, and hydrogen ecosystem also seen in part of Europe. So while the outline characteristic of Hydrogen Valley not necessarily apply to all projects labeled under these definitions, they most often have at least one of the following attributes in common. So DST expects to follow similar strategy as a local agglomerations of various hydrogen users. Shared infrastructures and joint supply source are essential to scale the industry and take the new hydrogen economy to the next level.
I have doing. I will do it. Doing. Forget. I'm going to again.
So I'm going to skip this slide. My time is okay. Let's skip this also. So these are the upcoming Hydrogen Valley recommended by DST along with the MNRE. So here you can see there are 4 valleys, Jodhpur HVIC, which lead by IET Jodhpur campus. Then we have Pune HVIC, which lead by NCL Pune. Then Bhubaneswar, which lead by IIT Bhubaneswar. Then finally we have Anert HVIC locations are Kochi, Alappuzha and Trivandrum region. And here are the details of recommendation of Hydrogen Valley Innovation Clusters. So here summarize which technology they are going to use and what is the production capacity, what type of storage and distribution they are going to adopt, and finally the utilization. So this is my last slide. The DST also coming up with the DST Hydrogen Valley Fellowship Program. So in order to formulate this call, we are conducting a stakeholder meeting on 28th March. If anybody interested to participate this stakeholder meeting, please send me an email. So this is my contact details. Thank you for your attention.